Hey, good morning, class. We're starting chapter 3 today, and one of the topics in our first section is what the idea of reflections. Reflections is one of the few, there's not many of them, transformations of the Cartesian coordinate plane that does not distort an object. It's called a rigid transformation. And I want to demonstrate this first one that we're going to look at called a reflection in GeoGebra today. And if I go to GeoGebra, this is like a place where I can type equations and such. If I wanted to, I can add my own image. So right now you can see I'm using an image called calculator, but feel free to add your own image as well. But what I'm going to do is I'm going to create a reflection. So in order to create a reflection, I need to have a line to reflect something about. And probably the simplest line I could use would be the x-axis itself. So I'm going to start by just doing a reflection across the x-axis, and I'm going to move this calculator up into this is the first second quadrant. So the quadrants are numbered starting here. This is quadrant 1, 2, 3, and 4. So I'm just going to leave the calculator in quadrant 2, and I'm going to scroll down to where I see the tool that says reflect. So it's under my transformation menu. So again, I'm hitting it says tools. So here's things. This is, yeah, tools. And then I'm going down to transformation and reflection. And it tells me down here, select an object to reflect, then the line of reflection. So I'm going to take this object and I'm going to reflect it across the x-axis. And you can see when I do, um, it's not that this calculator's, it's not that I have two copies of it. You can see something very specific is happening. In fact, if I come back up here and I grab the move tool, I can now grab certain points and I can move them around. But I want you to observe that, for example, that the keypad is off on the right of the original shape, and over here it's off to the left, right? So this has literally been flipped along the x-axis. It's a complete reflection. You'll notice the text is backwards as well. There's a couple things that happen with reflections that are kind of worth noting. So I'm going to make it so that the number 3, if you look real closely, the number 3 on the keypad on the original shape is at the coordinates x is -4, y is 4. And I want you to observe the coordinates after a reflection across the y-axis. So this is a reflection across y. Notice when I reflect across the y-axis, what was a -4 for x became +4. My y value stayed the same, right? So you can see this object, once I reflect it across here, it was, if this is the original image, it was at -4, 4. Now it's at +4, +4. You can see the same thing for some of the other keys. Like for example, if I look at there's a key right here that says program. Program looks like it is at roughly x is -6, y is 8, and you can see with the reflection, y is still 8, right? You can see the y value didn't change, but instead of being at -6, it is at +6. So if I take a look at this, I want to focus on the on button. So this shape over here, this is the original, right? This is my object. And over here, this is what I call the image of the object. And again, what I've done is I've looked at the the y-axis, and I've reflected this shape across the y-axis. It was over here on the left-hand side, and I reflected it over to the right-hand side. And I want to point out something. The coordinates of the on button, were at -6, comma 4. And after this transformation, and I should write down specifically what the transformation was. Let's write down, this is a reflect across y-axis. After that reflection across the y-axis, this point ends up at, my on button ends up right here, where x is positive 6 and y is still positive 4. So this suggests a rule for any time I want to do a reflection across the y-axis. And I want you to think about rules like this. And when you get confident that one of them is working, maybe write it down. But here's what I want to suggest. If I've got an x, y point, if I want to reflect across the y-axis, what I do is I take the opposite of what x is, and I leave y alone. Now, don't be confused by the fact that this is the negative number. What this says is that at this point, x is negative 6, and if I want to do a reflection, x is going to become the opposite of negative 6, and the opposite of negative 6 is positive 6. So that allows me to record, things that could go either way. So for example, if I have this point here, let's say that this point is my image, I know that its reflection is going to be way over here. Oh, I'm sorry. If I'm starting with this as my object, the image of that object would be over here. So I can reflect either direction. I can reflect the left-hand side to the right or the right to the left. This formula doesn't care. All it says is that if you've got an XY point and you want the reflection of that, you just basically take the opposite of X and leave Y alone. And of course, the beauty of GeoGebra is you're not limited to just one reflection. I could take this object and I could say, well, let's reflect it across the x-axis as well. So I've got this selected. Again, I come down here, reflect about a line. It says select the object and then the line of reflection. So I'm going to click the object again, and I'm going to click the y-axis. And you can see, oh, it's in a reflection. In fact, I'm going to take this object and I'm going to reflect it across y also. So same deal, reflection. I'm going to select this calculator and I want to reflect it across the y-axis as well. Whoops, that did not work. Did not work. Let me try that one more time. A reflection. I want to reflect this object about the y-axis. There we go. So now if I grab any one of the handles from my original image, right, as I move them, you can see that the entire thing is being transformed in real time. And one of the goofy things that I like doing occasionally is I like to automate these. This is definitely not part of something I expect you to be able to do, but it's just fun. I'm going to put a tiny little circle right here. Oh. Is there a better circle tool? Am I messing up? Oh, there it is. I just put this tiny little circle right here. And one of the things I can do is I can attach points to the circle. So the item I am looking for is normally in the point menu, and I don't see that, so I'm going to hit more tools. And I go down here to points. Here's the point menu, and I want to detach a point. So it says select point, then object to attach to. So I want to select this point right here that's at the corner of the triangle, and then I want to attach it to this circle. So what happens is it jumped to that circle, and what that gives me is the ability to right click that circle and I can turn animation on. And oh, it's not very fluid, but what it's doing is it's just slowly moving that point around the circle, and as it does, you can see all the other calculators are perfectly reflecting across the y-axis from the left to the right, and of course from the top to the bottom across the x-axis. So anyways, that's just a way to visualize reflections, and GeoGebra it's fun, it's free. I suggest you play with it. I am going to put a link to a GeoGebra sheet in today's lesson. Feel free to open it up and take a look at it. So your main assignment today is to complete this file using Cami, and basically it's a quote-unquote Cami assignment. But what happens on the first 6 objects here is I'm going to give you a shape, and I want you to do a reflection across the the line that I've given you. And a good tool to use to do that is on the drawing menu. They have a under shapes, there's a segment tool. So this segment tool is a pretty good tool to use to do this. And if I take a look here, I think I can zoom in. There we go. So if I wanted to do a reflection of this thing, I'm noticing kind of this down and over pattern. So you can see this first point is located here, and if I what I have to do then is I have to kind of visualize where this next point would be, or I could say where this next point would be. So again, I think from here to, let's see, it's going to be down to over to here, right? This would be what I would get from the reflecting this object across this line. So here's where I can start. From this point, I'm going to go, I could do it this way. I'm up 1, 2, 3, 4, and I can go this way, 1, 2, 3, 4. So I can see what happens. So if I can add another line segment from here to here, and then I have to go away 1 unit. And the thing right now, I don't even believe that I'm doing this correctly, right? As I do this, I'm very suspicious of the whole thing. But I do know that if I was to just observe this pattern going to the line using vertical and horizontal lines, if I go down, I'll do this corner right here. It should go to this corner. If I go down 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, that's working. What I need to do now is I need to have a segment. Let's do this point. I think this is going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, I need this segment right here. So again, I've just got my segment tools on in Cami. And I I, I don't know. I chose to do this one because I think it's probably one of the more difficult ones. But following those patterns like that, the down and then over, you should be able to connect. This is the object to its image, down to, over to. So it's basically. I think one thing that is true is if I connect each of these points, an object point to its image, I should be getting a bunch of lines that I think are perpendicular to the line of reflection. So that's that shape. Some of them that are easier, like this, I don't think is going to be super bad for us because I start here and I clearly go to this point, right? And then I'm going to come back to this point. So just go ahead and do a reflection for each of these. I think probably number 3 and number 4 will be the most challenging. Down below on question 5, oops, it says graph GLM. So you're going to graph triangle GLM and it gives you the vertices. And then it says, and then add and the line y equals x. So if you think about the line y equals x, your slope is 1 and your y-intercept is 0. So you should be able to graph that line. And then you're asked to reflect the triangle over the line y equals x, and it says, what do you observe? I don't know what you're going to observe, but you're going to tell me what you observe. And you're going to do that by grabbing the text box and just dragging. Oops. Oh, you can't. Oh, you can add a comment. No. No, I don't want a comment over there. I did that wrong. I think what you're doing is you're just going to grab the text box and just click somewhere. There it is. And now I can just, yeah, I can type. There we go. So you'll be able to type what you observe in this space provided after you've got this graph set up. Anyways, that's what we've got as you're working today. Please try and think, hey, what's the big idea here? Can I think about rules for transformations, and can I reliably do some reflections? And that's where we're going to end it. So I'm just looking for this completed page today. And again, I encourage you to play with GeoGebra a bit. This is Mr. Roberts. Have a great day.